Hello, welcome to my channel. In this video, I'll be discussing periodic table. This is a periodic table. The elements are arranged in tabular form with the column representing the group and the rows representing the periods. Elements are grouped based on the number of valence electron, or otherwise known as valency. Valency of an atom refers to the number of electrons in the outermost shell. Remember the Niels-Bohr's model of atomic structure, in which there is nucleus containing the proton and electron revolving around them. Okay, for this atom, the outermost shell is this. Okay, the number of electrons in this outermost shell is what is known as the valency of that atom. Okay, so the valency for this atom represented is 1, which corresponds to lithium. Okay, if there are 2 electrons in the outermost shell, the valency is 2, and it continues like that. The groups in the periodic table can be numbered from number 1 through 18, while it can also be numbered using the Roman figure and grouped into A, the number followed by A, or B. Those that are followed by A, they are group 1, 2, group 13, 14, 15, 16, 17, and 18, as you see here. Okay, while the Roman numeral can be followed by letter B, as you've seen here. Okay, the elements in the periodic table are generally divided into the metals, which represents all the elements here. They are the metallic elements in the periodic table. They have their specific physical property. What makes them metals is the fact that they lose electrons in their outermost shell and become positively charged ion. Okay, when an atom loses electron in its outermost shell, it becomes positively charged, and the elements that do that are the metallic elements. Their physical property include they are malleable, meaning that they can be beaten into sheets, and they are also ductile. They can be drawn into wire. Okay, so those are the physical property they have. Okay, they also have their specific density, which is usually higher compared to the non-metals. Now, the non-metals, these are the metallic elements. The metallic elements, I've talked about their chemical and physical property. On the right hand side here are the non-metallic elements. They tend to gain electron in their outermost shell because it is easier for them to gain electron than to lose electron. Okay, please take note. Hydrogen is not considered to be a metal. It is a gas. Okay. Amongst the metals, they are further divided into the transition elements, the transition metals, which are in this block. They are otherwise known as the D block. And also, these ones are the inner elements composed of the lanthanide and the actinide. I will talk more about their physical and chemical properties as we move on. So these are the different components of the elements in the periodic table. The last one I've not talked about are the metalloids. The metalloids have their specific property. They behave both like metals and like non-metals. They behave like metal in the sense that they can conduct heat and electricity. Okay? However, unlike metals, their conductivity increased with increasing temperature. Unlike the metals, whose conductivity increases with decreasing temperature. That's one major difference between them. Another difference between them is that because they are full conductor of electricity, they are they can also serve as insulator depending on how they are used. Okay. The metalloids are used as semiconductors in electronics. They are used as semiconductor in electronics. They behave like non-metals physically in the sense that they are brittle, meaning that they can be beaten into sheets. They are not malleable and they are not ductile. They rather break if you want to beat them into sheets. So they are non-malleable and non-ductile. They are brittle. Okay. Now, let's be looking specifically at each of the groups. The first group in the periodic table are known as alkali metals. Yeah, alkali metals, excluding the hydrogen, they are known to be highly reactive and soft. They usually have one valence electron in their outermost shell. Okay, for example, lithium has one electron in its outermost shell. Don't forget, this is hydrogen, helium. This is lithium. Okay, so they tend to lose this electron and become positively charged, plus one. Example, lithium lose its electron and become lithium ion, which is one positive uh, charge. They become positively charged because they lose negative. When they lose negative, don't forget that the number of electron and proton in an atom are the same. So when an atom loses electron, there will be excess proton in the nucleus of the atom. Therefore, they become positively charged. Beryllium belongs to group 2. This is group 2 element in the periodic table. They are known as alkali earth metals. They are known as alkali earth metals. And these alkali earth metals are also very, very reactive, although they are not as reactive as the alkali metal, which is group 1. And they tend to form alkali when they react with water, they form hydroxide. Okay. Alkali earth metal like magnesium are used in alloys, and calcium are used in construction materials because of its strength. Okay. They usually tend to lose two electrons in their outermost shell because their outermost shell contain two electrons. That is why they are in group 2. Okay, and when they lose two electrons, they become positive 2. For example, calcium plus 2, magnesium 2 pluses. So these two groups are called, they are otherwise known as the S block elements. S block elements. And that is due to the fact that their electron configuration, you can watch my video on quantum numbers and electron configuration. The electron configuration usually end in s orbitals. For example, hydrogen is 1s1, lithium is 1s2, 2s1. So they usually end in s orbitals. So that's why they are called s block. The third group that we'll be talking about is the boron group, which is this. Okay, the boron group, they have three electrons in their outermost shell, and they tend to lose those three electrons and become 3 plus. For example, aluminium lose three electrons in its outermost shell to become plus 3. In this group, boron is metalloid. I explained what metalloid is earlier in the first slide, while others are metals. Okay, all the remaining one, aluminium, gallium, and the rest are metals. Aluminium is, because of its low density and resistance to corrosion, it is used in aircraft. Okay, because of its lightweight, and also it's used in beverage cans. Okay, the next group I'll be talking about is group 14, elements, which can also be group 4, the carbon group. Okay, the carbon group, they have 4 electrons in their outermost shell. If you take notes, you will discover that the number of electrons in the outermost shell determines which group it belongs. And the number of electrons in the outermost shell is the group number of the element. Take note of that. And they exhibit a range of properties. Like carbon is non-metal, okay? While silicon and germanium is metalloid. The nitrogen group, group 5, have 5 electrons in the outermost shell, and they tend to gain electron. They compose of phosphorus and arsenic. Okay, because they tend to gain electron in their outermost shell and become negatively charged. Group 5 has Group 5 elements have 5 valence electrons, and example include nitrogen and phosphorus. Most of them are very ubiquitous in living organisms. The oxygen group, that is group 16 or group 6, they have 6 electrons in their outermost shell, and they tend to gain 2 electrons to complete the number of electrons in their outermost shell. Don't forget that in the structure of an atom, there is nucleus which contain proton and neutron and electron around them. The first shell has maximum of 2 electrons, while the subsequent shell has maximum of 8 electrons. Those in group 16, they have 6 electrons in their outermost shell and they want to gain 2 more electrons. Therefore, they tend to be negative 2, they tend to form negative 2 ion. For example, oxygen. Oxygen usually form negative 2 ion. Okay? Oxygen is very essential in respiration for living organisms, and so far is used in the production of tetraoxosulfuric acid. Group 17s are halogens, and they have 7 electrons in their atomic shell. They are highly electronegative in the sense that they tend to they want to gain one extra electron that is remaining for them to complete the electrons in their shell. And they are also highly reactive, although their reactivity decrease down the group. They exhibit different physical states at room temperature. For example, fluorine and chlorine are gases, while bromine is a liquid. So, as you go down, their density increases. They can react with alkali and alkaline earth metals. Group 8 composed of the noble gases, and they usually have uh, 8 valence electron, meaning that their outermost shell have completed number of electrons, 8. So they are usually inert. They are not reactive. Okay, they are stable. They are usually colorless and odorless gas at room temperature. And due to their non-reactivity, they have various applications. Like in it's they are used in balloons and as a coolant for superconductors. Okay. I talked about the metalloids earlier on, and I said they behave both like metals and non-metals. They have some characteristics that are similar to the non-metals and those that are similar to metals. Okay. So, but what is very important to take note in them is that as temperature increases, their conductivity increases, unlike the metals, whose conductivity reduces with increasing temperature. If you actually want a metal to conduct more electricity, you cool it to a very low temperature. While if you want metalloids, which are semiconductors, if you want them to conduct better, you increase their temperature. And they have various applications in electronics, okay, in computers, in mobile phones. They have various applications. Those are the semiconductors in this block. Okay. The transition elements, they have metallic properties and have very high melting point and density, and also they conduct electricity very well. They usually form colored compounds and have multiple oxidation states. For example, copper can have copper 2 or copper 1 oxidation states. Okay. Iron can have ion 2 or ion 3 oxidation state. So they exhibit variable oxidation states. Most of them act as catalysts. Even in nature, most of the reactions that take place in human, they need some of these as catalysts, like manganese, iron, zinc, all these they can act as catalysts even in human biochemical reactions. The transition elements are otherwise known as the D block elements. That is due to the fact that they usually have partially filled. Their electron configuration usually end in partly filled or completely filled d orbitals. So take note of that. I talked about this one, which are s block. This one is d block. Okay. The lanthanides and actinides are otherwise known as inner transition elements, and they are located at the bottom of the periodic table. Here they are. They are known for their magnetic and phosphorescent properties, and they are used in the production of very strong magnets and phosphorus. Many of them are radioactives, and they are used in nuclear reactors and weapons. For example, uranium, okay, is a radioactive substance, and it's used in medical in radiologic therapy, especially in the treatment of cancer. And plutonium are used in nuclear weapons, and uranium. Now, let's talk about the variation in properties. Let's talk about the variation of properties that occur across periodic table. First of all, let's look at ionization energy. What is ionization energy? It is energy that is required to remove an electron from a gaseous atom. And this ionization energy tends to increase across the periodic table from left to right. The reason is simple. Those in group 1, they have one electron in their outermost shell. Those in group 2, they have two electrons. Those in group 3, they have three electrons. You can see that the energy that you need to remove one electron will likely be lower than those that you need to remove two electrons. And the reason is simple. Because as they go on, the electron increases, this proton too also increases in the nucleus. So as the charges increases, the strength of the force, electrostatic force between the proton and electron that keep the electron moving around the nucleus in an orbit increases. Okay? So because there is one, let's say there is one proton here, one electron. Here there is two protons and two electrons. So the strength of the force increase. So you require more energy. So the ionization energy increases across the period. Now, when you are going down the groove, the story is different. Because as you are going down, the number of shells increases. Okay? The number of shells increases. As the number of shell increases, the distance between the nucleus and the outermost shell increases. So the force, the electrostatic force between the electron in the outermost shell and the proton, also the distance between them increases. Therefore, the force itself will reduce. So you require less energy to remove the outermost electron. And that means that the ionization energy decreases down as you move down the group. Okay? That is that for ionization energy. Let's move to the next one. Ionic radii. Let's talk about ionic radii. Ionic radii is the radius of the ion of an element. Let's say, for example, lithium, which has three electrons, two in the core shell and the remaining one in the outermost shell. Okay. When it loses this electron, what happens? The radius reduces because this shell is no more there, right? So it means that for electropositive elements that tends to lose their electron and become positively charged, their atom, their ionic radii usually become smaller. Okay, their ionic radius, their ionic radii usually become smaller, while those that tends to gain more electrons, the anions, their ions, they are usually larger than their parent atom due to increased electron-electron repulsion. For example, let's look at oxygen. Oxygen has six electrons in the outermost shell, right? And it wants to gain two more electrons. When those two electrons come, what happens is because of the increased number of the electron, the repulsion force between the electron become more and they push this cell further. When they push the shell further, what happen? The radius become more. So for anions, the ionic radii increases compared to their atom. The next property we'll talk about is electron affinity, and that is the energy change that occurs when an electron is added to a gaseous atom. Take note, an atom that want to accept electron will not want you to expend much more energy. It will rather give you energy. So their energy can actually be negative, can have negative value sometimes. That is when they release energy as they gain energy instead of them waiting for you to supply energy for them to gain. So generally, it becomes more negative across period from left to right. That is because rather than waiting for you to supply them energy before they gain electron, they will rather release it. So, and when a reaction release energy, that is when they are exothermic. It means they supply energy when that reaction happen. So the same thing as you move across the periodic table from left to right, atoms tends to release more energy as they gain electron because they do that easily. They don't even wait for you to give them energy before they do that. So they are happy to gain electron. As they gain electron, they give you energy rather than giving them energy for them to take electron. They rather give you energy. Okay. Electronegativity is a measure of tendency of an atom to attract a bonding pair of electron. Okay. And what actually happens is that it increases from left to right. That's simple. When two atoms form a covalent bond like this and they share an electron, right? Both of them tend to pull the electron towards themselves, right? And which one will pull more? There are two factors that can come into play. One, the distance between this one, between their nucleus and the electron they are pulling, that is one, which will be determined by the number of shell they have, right? And the second one is the number of proton in the nucleus. Okay. That is why when you go from left to right, You know the number of proton increases, right? While the number of shell remain the same, right? So therefore, the electronegativity, the tendency for them to attract that electron increases because the number of proton increases. Okay? And like I said, proton is positively charged, electron is negatively charged. They attract each other. So as these charges increases, the force of attraction between them increases. So as you move across the periodic table, the proton charge in the nucleus increases. So also the electron and the strength of attraction between them also increases. Therefore, the electronegativity increases. Electronegativity is a tendency to pull electron towards themselves. Okay? So, and because the charge, proton, the positive charge increases in the nucleus, they tend to pull it more towards themselves. That is when you are moving across the period. But when you are moving down the group, what happens? Let's see. Let's reason it out. I told you that the force of attraction between the nucleus and the electron, that's electronegativity, the proton pulling the nucleus, pulling the electron towards themselves, it depends on both the number of charge in the nucleus and the distance. As we move down, the distance between the nucleus, which contain the proton and neutron, and the outermost shell increases, right? The shell increases as you move down the group, right? So the force between them reduces because the distance increases, like I explained here earlier, right? So therefore, the electronegativity decreases down the group. Okay, so it increases across the period and decreases down the group. And in addition to the increasing size, also the electron shielding, that is the force of repulsion between the electron, the different number of electrons that are there also. Because the electron repel each other, they make this thing larger. Okay, and this increase the distance between the outermost electron and the proton, and the electronegativity reduces. Okay, and this force of attraction is also counterbalanced by the force of repulsion by the electron that's already there with the electron that is incoming. Okay, so that is electron shielding. Now that we've gone through this topic extensively, let's go through some questions to test our knowledge and understanding, and also to reinforce some of those things that we have known. Question number one: which element is in group one of the periodic table? Take notes that you need to know the first 20 elements in the periodic table offhand. Okay, that is very important. Helium belongs to the noble gas, the inert gas, right? That is group 8, right? Sodium belongs to group 1 because there's only one electron in the atom shell. Helium has two electrons, okay? And they have completed their shell, the only shell they have completed it. So sodium belongs to group 1. Chlorine belongs to what? Group 7 because they have 7 valence electrons. And zinc belongs to the transition element. So the correct answer is B. Which of the following is a halogen? Halogen are group 7 elements, right? And they are majorly gases. And like I said earlier, as we go down the group at room temperature, their density increases. Okay, chlorine is gas, fluorine is gas, chlorine is gas. But iodine is liquid. So which of the following is an halogen? Halogen is fluorine. Is the correct answer. Which property increases across a period from left to right? Atomic radius, that is not correct because when electron is being added to the same number of shell, when you move across the period, you have the same number of shell. or more electrons and protons are being added. So the force of attraction between them increases. So radius tend to decrease rather than increase. Ionization energy, the energy needed to remove electron from an atom. Does it increase as you move across the table? Yes, because the number of valence electron increases, and as it increases, the amount of energy you need to remove it increases. Okay, so this increases. That is correct. Metallic character. Hmm. Metallic character is rather non-metallic character because as you are moving from left to right, you'll be moving towards the non-metals. So this is not correct. None of the above. That's not correct. The correct answer is ionization energy. It increases from left to right. What is the characteristics of noble gases? Noble gases belong to group A's, right? Or group 18. And we know that their valence electron is 8. So they don't want to gain, they don't want to lose because they are stable in the state. So they tend to be inert and non-reactive. So the correct answer is D. Which group contains transition metals? Recall that the groups are numbered from 1 can be numbered from 1 to 18. They can also be numbered as 1A, 2A, 3A, etc. And also 3B, 4B, etc. Right? So this numbering system is 1 to 18. Now, they now say which group contain transition metals, right? The transition metal are those between 3 and 12. This is the correct answer. What trend is observed for electronegativity across a period? Electronegativity is the tendency of the atom to attract extra electron, right, and become electronegative. You see, electronegativity to become electronegative, right? So, what happened to it as we move across the period? When we move across the period, recall that the number of proton increases, right? And the shell is of the same number, right? So, because the positively charged is increasing and positive charge want to attract negative charge, it tends to want to attract more electrons. So, as we move across the period, this tendency to attract electrons themselves and become electronegative increases. Okay, so decreases is not correct. Increases is correct. Remain constant, it doesn't remain constant because of the variable that is brought about by the distance of the shell and also the number of the charges varies irregularly. I'll leave this question for you to answer. I know it may be controversial. Let's open up discussion about it and let me respond. And if you want me to make special video on this question, it's very interesting. You can comment in the section below so that I will make special video on that. Okay, let's go to the next question. What happens to atomic radius as you move down a group? I explained this. You should be able to answer this. Which element is classified as an alkaline metal? This is a simple question. Which element is in group 18 of the periodic table out of this? Answer in the comment section below. What is ionization energy? It's simple. So I'll leave the remaining questions for you to answer. You can comment your answer. Write your answer in the comment section. Let's discuss. Okay. Please like this video, share with your friends for them to benefit, and subscribe to my channel to encourage me to make more video. What keeps me going is you're watching this video, liking it, subscribing it, and sharing it. Okay. I really appreciate that. I appreciate your comment a lot. All right. These are the questions. Thank you. Please, but before you go, hit that like button, share with your friend, and subscribe. That's the energy that keep me going. Okay? Till I see you in my next video. Take care and bye bye.